Hey guys, I hope you all are doing good. In the last video, we covered some basics about sets, and in this video, we will cover some further concepts in the sets itself. We'll start with understanding what are subsets and supersets, and we'll move on to other concepts as well, right? So let's start with understanding what are subsets and supersets. I'll try to read the definition and then I'll try to explain it with an example. I think it will make things a lot more easier, right? So a set is called a subset of the set B. A set A is called a subset of a set B. We represent it with this symbol if every element of A is also in B. We use the symbol C with a dash to represent it, right? So this is the definition of a subset. Let's try to understand with a very basic example. Consider I have two sets, A equal, let's say A, B, C, and I have B equal A, B, C, D, E. According to the definition, a set A is called a subset of B if every element of A is also in B. So if you take a look at this example over here, we can see that every element of A is also in B, right? That's the important part. So we have the small a, it's a part of B, small b is part of the big set B, small c is also is a part of B, right? Hence, I can say that A is a subset of B. I hope you understand the basic definition of what is a subset. Moving on, let's try to understand what is a proper subset. So if A is a subset of B and A is not equal to B, then we say that A is a proper subset of B and represent it with just a C kind of symbol, right? Now, both these definitions might seem very confusing at first, but they have very simple and quite easy difference. So, but very important thing to remember is the fact that they have a clear difference and don't confuse both of them. So don't consider that, don't mix up their definitions is what I'm trying to say, right? So the basic point is we can see that A is a subset of B, which is a set A. Every element of set A is also in B. We can see that over here, every element of A is also in B, right? Hence, we can say that this point is true. And there's another condition in the proper subset definition. A is not equal to B. Then we say that A is a proper subset of B. In very simple terms, in the case of a proper subset, the set A, the subset set, has to be smaller than the other set, right? So in this case, you can see that A is smaller than B. It contains a little less elements as compared to B. B has extra D and E over here, right? So the point is, A is a subset of B, that is, all the elements of A are also in B, and it also satisfies this another condition over here, which is that A is not equal to B. So in this case, A would be a subset of B, but A would also be a proper subset. So both these conditions would be satisfied. I'll try to explain it with another example. So consider I have this another set, let's say C. Now, if I ask you the question, is A the subset of C, which is A subset of C, and is C subset of A? The answer to both these questions would be yes, right? Because according to the definition of a subset, every element of A is also in B. So every element of a set should be in the other set in order for that set to be the subset, right? That's kind of the definition. So we can see that every element of A is in C and vice versa as well. Every element of C is also in A. So hence, I can say that both these statements are true. But now let's try to understand, do you think is A a proper subset of C? A proper subset of C, C proper subset of A. Now, when it comes to the proper subset, just like I said, in order for A to be a proper subset of C, they cannot both be equal. C has to be somebody which has more elements in it, right? And in order for C to be a proper subset of A has to have more elements. But as we see in this example over here, both these sets are equal to each other. And according to the definition of proper subset, they should not be equal. The two sets, they should not be equal. So hence, this over here would be incorrect. I hope you understand both these definitions. Now let's try to understand what is a superset. If you have a good understanding about what is a subset, then it's quite clear to understand what is a super subset. It's just basically the opposite of what is a subset, right? So a set B is called a superset of A if every element of A is also an element of B. So very simple example would be over here we can see that A is a subset of B and B would be a superset of A, right? That's the basic definition in this case. So it's just vice versa, and again proper superset would again be the same thing with the difference that B would be a bigger set. So if B is the proper superset, then it has to have more elements as compared to the subset of it. I hope that makes the definition very clear, right? So let's try to move on to the next concept now. Okay, so let's continue with set operations. So just like in math, we have different operations, right? So for example, we have plus, minus, multiplication, subtraction, etc. So for example, I'm just giving a basic example, right? Let's say 2 plus 3, we can do operations like 2 multiplied by 3, 2 divided by 3, etc. Point is, we have these mathematical operations that we perform in maths, right? In order to just supplement our understanding. Just like that, in sets also, we have these few very important operations. So we have union, intersection, difference, and complement. We have the definitions over here. So we'll read the definitions, try to understand them, and then I'll explain them through with very easy examples, right? So A union B means all the elements of A or B. So when I talk about a union, so let's say I say A union B, it basically means all the elements of A combined with all the elements of B. So I'll try to explain it with a very simple example. Let's say I have A equal A, B, C, D, E, and I have B equal F, G, H. Then simply the union, which is A union B, would be A, B, C, D, E, F, G, H. So all the elements of A or B. Now another example, this is kind of not a good example to be honest, so I'll give another example of it. Let's say if B is A, B, D, F. Now, if you try to look at it, A and B have 3 elements in common, which is A, B, and D, right? Now, F and E are the only different elements in this case. But when I do the union, all these elements would be combined into one. So, the A union B would be equal to A, B, C, D, E, and F as well. I hope that makes sense, right? So basically all the elements in A or all the elements in B combined together, right? And so you might be wondering, if you're wondering why I have not written the A, B, and D multiple times, the reason is multiplicity does not matter in sets, right? That's what we discussed in lecture 1. So writing this D multiple times would mean the exact same thing as writing it a single time in a set. So I hope you understand what is a union. Moving on, let's try to understand what is the intersection. So A intersection B means all the elements that are in both the sets. Okay, let's try to understand what this means. Now in union, we basically combine all the elements that are in both the different sets. The intersection means all the elements that are common in both the sets, right? So for example, let's say A is A, B, C, D, and B is A, B. Their intersection would simply be all the elements that they have in common with each other. So if you look at it, they have A and B common with each other. So this would simply be A comma B. If you try to look at it, this basically means the elements that are in A or B, and this means the elements that are in A and B. So the condition difference is, in this case, the elements in the intersection should be the ones that are in both A and B, and in this case, they have to be in A or in B, right? I'll move on and explain this concept of or and in future concepts as well. But for now, just try to understand this difference. Over here, we have a or, and in this case, we have a and. Right? So I hope you have a good understanding of intersection as well. So moving on, let's try to understand what is the meaning of a difference. A minus B, or I'm just saying it this way, so A difference B means all the elements in A, but which are not in B, right? Let's try to understand with a very simple example again. If I have A and B over here, A minus B would simply be C comma D, which is all the elements in A but not in B. It's kind of like what we are doing is we are taking the elements that are in B and we are plucking them out from A as well. So what we are left with is just the A stuff, right? I hope that makes sense. So it's kind of like what they both have in common, we are plucking it out from what we have subtracted. So since we subtracted B over here, we took all the elements in common. Let's say if I had some set C equal, which just had the single element D, in that case, A minus C would result in A, B, and C. We would have plucked out the D element from the set A, right? I hope that makes sense. So we have covered union, which is all the elements combined together in both the sets. Intersection, all the elements that are common in both the sets, that would be the intersection. Difference, all the elements which are in this set on the left side of the equation, and removing all the elements that are common between both of them, right? So I hope that makes sense. And complement means all the elements we represented with this sign. So basically a dash on A. There's also another representation for it. So it can also be represented like this, right? So if you see this symbol or this symbol, it basically means the same thing. So a complement means all the elements not in A but in the universal set. Now I haven't introduced the universal set concept in like previous lectures, so I'll try to explain it with a simple example. The universal set is basically the set of all the elements in a problem. So for example, in a problem, let's say I'm talking about birds, right? The universal set could be the set of all the birds that we have. Or let's say I'm talking about a problem where I have to, where there's a set of different types of elements. Then the universe could be the set of all the different animals that we have. So it's basically the universe of all the elements in a single problem context, right? So a complement means all the elements not in A but in the universal set. I'll try to explain it with a simple example, right? So let's say the universe is 1, 2, 3, 4, 5, right? For a problem like, consider this is the universe of it. We just need these 5 elements, 1 to 5, right? And if A, let's say, is 1, 2, then A complement would be all the elements which are not in A but in the universe, right? So all the elements which are kind of like around A. So in this case, it would simply be 3, 4, and 5, right? So A complement would be this. Now, just another concept I want to cover is, if I complement this again, what do you think will happen? This will result in the same set once again, which is going to be A, right? So it's just a quick property which I'll cover in the next lecture as well, but it's just a quick thing to understand and remember as well, right? So I hope you have a good understanding of union, intersection, difference, and complement, right? Okay, let's move on to other concepts. Okay, Now I would like to introduce another concept in sets, which is the Venn diagrams, right? So the basic thing is that while these definitions are quite easy, the Venn diagrams are basically dramatic representations of these sets, right? So they make things kind of a lot more easier to understand, and I think that will make these concepts more clear. So I'll try to show what a Venn diagram is, and then I'll try to explain all these concepts, union, intersection, difference, and complement, on a Venn diagram, right? So basically a Venn diagram, we make it just like it's kind of like a rectangle, right? And for each set, we draw a circle. So for example, let's say we have set A and B. I'm going to draw this circle like this. So this represents A and this represents B. Now, if you try to look at it, both these circles are intersecting each other at a certain point, right? What this means is the fact that both of them have some elements in common with each other. So A and B have basically some similar elements. It could be some random elements, right? But if in the case that they were not connected to each other, right, which is they were not intersecting each other, let's say I have like this. This would mean that both of the A and B sets have nothing in common, right? So that's very quite important to understand. Now, if I draw another set C over here, what do you think this would mean? This would basically mean that while A and B have nothing in common, B and C both have common elements with each other. And C with A, they don't have anything common with each other. I hope that makes sense, right? Okay. Now let's try to understand union, intersection, difference, and complement. I missed one more thing. This entire rectangle is going to represent the universal set. So this entire thing is the universe, right? Just like I said, universe is basically the entire, I should say all the things, the big set which is related in a problem. So it could be some numbers, it could be, like anything which is in the entire universe in that case. So let's try to understand all these things with the Venn diagram. Starting with the union. Okay. So first I've drawn the entire rectangle which represents the universal set. So this would be universe. Now the union, I need to see how to represent a union, right? This is A and this is B. So what I'm going to do is I'm going to basically shade in the portions which would represent the union. So let's try to read the definition once again. All the elements of A or B, which is all the elements of A and B combined together with each other. So we have the elements of A over here, elements of B over here. So the union would simply be all the elements combined together. This entire shaded region would represent the union of A and B, right? And this is the universe. Just try to, I hope that makes sense. Okay. Now let's try to understand what would be the intersection. So intersection, draw the two sets again. According to the definition, means all the elements that are in both the sets A and B. So if you try to look at it, all these elements, which is on this side over here, are going to be the elements that are just in A, right? This side is going to be all the elements that are in B but not in A. But this common region over here, this is the one which would represent the union in this case. Sorry, the intersection, right? Which is the elements that are common between A and B. I hope that makes sense. Okay. Now let's try to understand what is the difference. Okay, so according to the definition, just like we said, means all the elements in A but not in B. So the point is, we first see all the elements in A, we compare it with B and pluck out all the elements that are in B over here. So what do you think are all the elements which are just in A? They're going to be this entire region over here. So this entire region is going to be the one which is just in A but not in B. I hope that makes sense, right? So we have understood union, intersection and difference. Now let's try to understand what is the complement. So we have the universal set which is represented by the entire diagram or the rectangle over here, and then we have A. So if I talk about just A, it would be this entire circle. But when I talk about the complement means all the elements not in A but in the universal set. So it basically means all the elements that are around A. So in this case, it would basically be all the entire region which is around A. Right? This entire region around A, the shaded region, would be the one which is going to be the complement of A. Right? So we have covered all these 4 different examples. Now I'm going to be giving questions based on whatever we have covered in this lecture, and then try to solve those questions, and I'll cover them towards the end. Hey guys, I hope you have solved all these 3 questions. So let's start with question number 1. Given A, which has elements 1 and 2, given B and C, we're supposed to solve for if there's true or false, right? Let's start with question number A. Is A a subset of B or not? So let's try to understand the definition once again, right? A is a subset of B if all the elements of A are in B, right? Now, if I take a look at it, all the elements of A are in B as well. 1 and 2 are in B as well, right? So this is going to be true in this case. Moving on, is A a proper subset of B or not? Once again, just a quick tip, don't confuse between these 2 symbols over here, right? This means a subset and this over here means a proper subset. Okay. So is A a proper subset of B or not? Now in the case of a proper subset, I'm going to say the definition once again. A, all the elements of A are in B along with both the sets are not equal to each other. Basically, I can say that B is a bigger set. If that's the case, then this is going to be true. So there are 2 conditions in case of what is a proper subset. All the elements are in the other set plus both the sets are not equal to each other, right? And this satisfies both the conditions. So this is going to be true once again. Now moving on, is A a proper subset of C or not? In this case, if you try to read the definition once again, all the elements of A are in C, so one of the conditions for a proper subset has been satisfied, right? But A is not equal to C. Sorry, A is equal to C, right? And according to the proper subset definition, both the sets should not be equal to each other. So this is going to be false in this case. And again in D, it's going to be false once again. As you can see, all the elements of B are not in C. So the first condition itself is not satisfied, right? So this is going to be false once again. So if you have a confusion in questions like this, try to read the definition and try to remember that definition once again. Figure out if that definition is being satisfied by the question. And if that's the case, then you're going to do good. Okay. Moving on, we are given set A, B, and the universal set. Find the following. So we have to solve for union, intersection, difference, and complement, right? Okay. Let's solve for the first one. What is A union B? A union B basically means all the elements of A or B combined together in a single set, right? So basically, it's going to be all the elements in A, all the elements in B, which is 1, 2, 3, 2, 3, 4. Now, the point is that it doesn't matter if I write it multiple times, because in sets, multiplicity does not matter, right? So in reality, this is basically just 1, 2, 3, and 4. I hope that makes sense, right? Basically, all the elements of A or B combined together in a single set. Moving on, let's try to understand what is the intersection of A and B. Intersection basically means all the common elements between both of them, right? So all the common elements in this case are going to be just 2 and 3, right? So this is going to be 2 comma 3 in this case. Okay, moving on, let's try to understand what is A difference B. A difference B basically means I have the set A and I'm subtracting it or taking out all the elements which are in common of both the sets, right? So I'm given A, which is 1, 2, 3, and I'm given B, which is 2, 3, 4. When I subtract it, I'm going to take out the common elements, which is 2, 3 in this case, right? So I'm going to be left with just 1 over here, right? Now, since A doesn't have this element 4, I'm not able to really subtract it, right? So it's going to stay there, but it's not going to affect the subtraction or the difference in this case. Okay, moving on. In B minus A, it's simply going to be 2, 3, 4 minus 1, 2, and 3. So this is going to be 4 in this case. I hope you were able to understand this question, right? Basically, take out all the common elements from the earlier set, I would say. Okay, A complement. Now, according to the definition, the complement is basically all the elements outside of that set in the universe, right? So A over here is 1, 2, 3. In the universe, we also have these extra elements, which is 4 and 5, right? So the A complement is just going to be 4, comma 5. Okay, moving on. Let's try to understand A union B complement. Now, this is a bit more tricky question because it combines two different concepts, right? It combines the union and it combines the complement with it. Now, when you have these tricky type of questions, I would say start with the very basics, start from the inside, solve for a single part, and then solve the more complicated parts, right? What I'm trying to say is, I'm going to solve for the union first, find that value, and then try to solve for the complement of it. So in this case, I already know what is the union. It is 1, 2, 3, 4, right? So 1, 2, 3, 4. Complement, which is going to be, now the universe has an extra element in this case, which is just 5, right? So the complement is just going to be 5 over here. I hope you were able to understand all these concepts, right? Okay, moving on. Let's try to solve question number 3 now. I've left the space for basically this question. So let's start with part A. So this is the universe. This is going to be set A and this is going to be set B, right? We're supposed to solve A minus A intersection B. So this is again a complicated question, right? It combines intersection with the minus symbol or the difference symbol, right? So I'm going to start with solving for the intersection first and then apply the difference on it. So the intersection between both these sets is simply this common region over here, right? And I'm supposed to take this region out from A. A is this entire set and this is the intersection of A and B. So what I'm left with is just going to be this region over here. So I hope that makes sense, right? Okay, moving on. Let's try to understand the solution to part B. So given B, A, B, and the universe, right? Let's first try to figure out what is A minus B and B minus A. A minus B is simply going to be this region over here. And B minus A is going to be this common region. And if I take the union of it, it basically means both of these regions combined together, right? So the solution is simply going to be this entire shaded region, except this common portion in both of them. So that's going to be the answer. Okay. Now let's try to solve part C. So first let's try to figure out what is going to be the B complement in this case, right? So I have A, I have B, and the inverse. B complement is simply the entire region around B in this case, right? Which is all the elements which are outside of B. It's simply going to be this entire region except this circle, which is the B, right? Now I'm supposed to take the intersection with the set A. Now, when I take the intersection means the common elements. So if you think about it, this entire region and common with what is A, right? I'm going to be left with simply this region over here. And this is going to be answer to question number 3, right? So if you were able to solve all these questions, that's a pretty good job. And you are doing good in this case. I would say stay consistent, keep solving these questions, and I'll see you in the next lecture.